I know where there's some, right here in the hall, clerk.
No, Molly, I have
Okay, here we are back with the Zenith H1080 chassis. We've moved to the indoor closet because the outdoor closet, or the upstairs closet, was getting too cold. Winter is set in here. So, cleaned the top layer of gunk off and revealed what looks like might have been a catastrophe at one time. And that's, see if I can zoom in here, yeah. That's all this stuff. And I can see marks right there where someone in the past has tried to scrape that stuff off. But what it means to me is that this power transformer had a meltdown, or one that looked sort of like that. Had a meltdown and spread gummy tar all over the chassis. And so I looked up this number. This is indeed a Zenith power transformer, but not the original model from this radio. And you've already seen the audio output transformer here. It's generic. I can't find its numbers anywhere. Google the heck out of them and they don't appear. And it has just a ton of leads. So what does that mean? Let me turn this over. What probably means, well, let's start with this fact that these old radios have no fuse. The power comes in, gets hardwired to wherever it's going in there, and when something goes awry, it usually takes out some components. Had it been fused, it probably would have survived the event, whatever the event might have been. However, it wasn't fused. It will be. One of the things that I always do to all the chassis that I work on is add a polarized plug to the end of the power line. Cut this one off. It's in the way. Throwing it away. I'll add a fuse in here, and I'll fix up. There's a death cap roaming around in here somewhere. I'll fix that up as well. So all radios get a fuse now from me. A polarized power line. Particularly these ones with power transformers. It's trivial to do that kind of work. But it doesn't have the correct power transformer under here. It certainly doesn't have, I mean, this was a heck of a job here. And that's some wiring there. So this was cobbled together out of, I would guess, parts. I don't know. I don't know what's happened to it, but I would guess it's cobbled together out of whatever was lying around. What I need to do, what I'm going to do, is look at the power requirements of this chassis, mostly output tubes and stuff like that. But look at those. Count up all the wants and needs of the tubes and resistors. This cam dome, that former cam dome, there's now 2 or 3 other power resistors, and see what the current needs are for this chassis. Then I'm going to do 2 things. I'm going to reverse engineer what's going on with the power transformer. It's marked as being a 100-watt power transformer. It may very well be. It may be just fine, but I won't know that until I prove it to myself. The second thing I'm going to do is, what I'd like to do is find a replacement, the original transformer, and I've got searches out for them now. But nothing's turned up so far. And I haven't started looking for a spare chassis either. But what I am going to do is see if this was put back in close to appropriately for the radio and for the speaker. This great big honking speaker, all 12 inches of it, is a 4 ohm speaker, not a, I would have expected it to be an 8 ohm, but it's not, it's 4 ohms. And if you ever want to know how to figure that out, just put your DVM across the 2 leads of the speaker and round up. This happens to be 2.93 ohms, so you round up to 4. Works every time. So this speaker, as pretty as it is, if it's not being driven appropriately by the output transformer, it's just not going to sound good at all. But more interestingly, let's take a look at the schematic and see if we can see what might have caused this terrific damage, blown out power transformer and audio transformer. Given the age of the work, I presume it worked to some degree after the blow up and repair. But we'll see if we can make it better. So let's take a look at the schematic. For the Zenith H1086R chassis. And I did discover that this is the Z version. If you'll recall, on the back panel of the chassis stamped into the metal were a couple of numbers, and one of the subscribers noticed that, or told me, and I thank him for that information, that they were probably tube designations, which they indeed were. And they had to do with right down here. Well, we'll look closer here in a minute. Anyway, this is a Z chassis, and where we want to focus is right down in this lower right corner. This is where the power is and where the output section is. There's that tone on the front panel business is right here. But we want to look right here and see what's going on there. So let's get closer. Let's start here. This is where the AC comes in, obviously. Here's the noise suppression set of capacitors that cross the power line. I'll replace these with appropriate safety caps, as I will these down here. Choke, on-off switch, and here's the power transformer. Now, fortunately, they have the impedance resistance, actually, of each of these coils. The primary is supposed to be 3.5 ohms. This secondary for 6.3 volts is supposed to be a half an ohm. The 2 sides of the secondaries are 100 each, and then the 5 volt is supposed to be half an ohm as well. Here's our full wave rectifier. It turns out that this 5Y3 tests bad. It may or may not work, but it tests bad. I didn't even try it, of course. Output is 340 volts, and then we go through some filtration right here, and then we start distributing power. Up here is where our 6V6s. This set has a push-pull output stage, which is very efficient, but it uses 2 6V6s instead of just 1, and that's fine. Up here is the inverter for this tube, as I recall. This is the one that can be either a 6C4 or a 9002. And that's one of the things that indicate that this is the Z chassis. And by the way, this 6C4 had a short, so these 2 tubes are out of commission. All the rest tested fine, including the 6V6s. So if we look at the spec sheet for a 6V6, we'll see that it has a very specific plate voltage. It likes to run at a plate voltage with a maximum of, as I recall, maximum plate voltage of 315 volts. And that's pushing the tube pretty hard. So on this diagram, where the plates are, you can see 315 volts. So they're driving 315 for this one. It reads to me 310 for this one. So they're pushing those tubes pretty hard, which means there may be a fair amount of current. These are cathode biased by this 2 watt 270 ohm resistor, and if that resistor fails toward a short, it'll drive all kinds of current through those. It depends on its composition. If it's wound, it's probably still okay. It all depends. Anyway, so one of the things I've got to do is check out this resistor, and then once I find out it's in the right zone, then I'll feel a little better about bringing it up once I've made all the other checks. But the point is, the 6V6s are being driven to as high a plate voltage as they can stand, according to the specs. So that could be, that coupled with a failure of some kind, either in this resistor or someplace else, could draw a lot of current through here. And when you draw a lot of current through the power transformer, you can't help but draw a lot of current through the audio output transformer as well. It's just part of the system. In fact, this 310 volts is derived on the far side of the audio output transformer primary. Interestingly enough, it's a center tapped primary, which would suggest that they're doing some biasing for these 6V6s with maybe this resistor. I'm not sure. I'll have to look more closely. But at any case, these these 3 tubes right here are the biggest power hogs in the entire system. And if any place was going to cause that to melt down and that to melt down, it would be right in here. So we've got to proceed fairly carefully. So let me tell you what I'm going to do. This radio is full of wound copper wire, and by that I mean a lot of coils, a lot of chokes. So what I'm going to do is go through and ohm out every transformer, including the IF transformers, every choke that's lying around, and there are a ton of little tiny chokes here and there. I'm going to find out whether they are all okay, and I'll mark them on the schematic. Secondly, I'll start replacing capacitors. I think I want to, since this is only a couple of 40 microfarad caps for power conditioning, I will try to restuff them into one of the cans that exits the top of the chassis. But that's my strategy, is to check all the chokes, all the transformers, then check. There are a lot of heavy duty. The CAN dome is out of service, but has 3 replacements that need to be right. So I'll check those, and then I'll start replacing the caps. I'll replace the power caps, and then all the other waxy caps. And along the way, I'll check as best I can the fair number of ceramic caps in here that are probably fine unless they've been torqued in some way. So, new fuse, new line cord, new safety caps, check all the transformers, check all the chokes, replace the caps as appropriate. That's our process going forward. I've ordered a new 6C4 and a couple of 5Y3s. I should have had one of these on hand and didn't for some reason. Okay, that's it. Those are our orders. So we'll proceed from here. So long, and see you next time. Stay safe out there. Bye.